Hey everyone, this is the second video in this series where we are talking about the main concepts of the C# language. So we are starting by explaining these concepts, and then we're going to speak about the use of the C# language inside Unity, how we can, for instance, translate an object from a point A to point B. So we're going to firstly talk about these main concepts, and then we will move forward. So in this video we're going to talk about classes and what a class is. A common example when we are explaining classes is a class called person. So a class we use to group together things that have something in common with each other. So for instance, what kind of thing a person class should contain? It should contain a variable called name, which will be of course the name of this person. We also can use a variable ID, which could be of type int. We can also have methods in our classes, and for a person we can have methods like walk, eat, sleep, and we will see in this video how to use these methods, how to invoke these methods outside of the class. We will understand better the concept of the access level of a variable or of a method. So let's start by creating a new script. I will call it person, because this will be the name of my class. So when we create a script in C# or in JavaScript, we are actually dealing with a class. We are working with a class because if you go to the first aspect of the script, we can see that we have a class defined right here, public class person, which inherits from monobehavior. Inheriting from monobehavior turns these methods right here into a useful stuff, because these methods are automatically called by Unity. So if we do not inherit from monobehavior, these methods are just regular methods. They don't have this automatic invocation by Unity. So we will not be working in this video with this monobehavior inheritance. Okay, so here's my script. So let's treat a script as a class. Here I have my script called person, and inside this script called person I have a class called person. Okay, so in this video, as I said, we will not be treating inheritance, so I will remove this part of my class definition. Okay, so now we have a regular class. If we try to attach this script to an object, we can try this. We will get an error. Let's try. Okay. We have this error right here that our script needs to derive from monobehavior in order to be able to be attached to an object. So now this class will work as an instance class, and we will treat this later on this tutorial. Okay. So the first thing we're going to talk about is these common methods and variables that a class group together. Okay, so in this class called person, we will group together things that has in common with person. For instance, we can start with this person's name, public string name. Here is where our access level turns into handy stuff, because when a variable is public, this means that the content of this variable can be accessed from outside of this class, and also the content can be changed from outside of this class. And we will see this in a moment. We can also have a public int called ID, and we can have like dozens of variables in this class, but we will keep it simple with just these two variables. And we can also have a method called walk, for instance. So let's define it as being public void. It will not return it will return nothing. Let's call it walk. Okay, And here, let's not deal with a bunch of code. Let's just deal with print. When we are not inheriting from monobehavior, we do not have access to this print method. We can see that when we type print, we have no matches. So we need to type debug.log. This is exactly the same thing as print. It is just useful when our class do not inherit from monobehavior. Okay, so when our class do not inherit from monobehavior, we will need to use this log method of the debug class. So here we can print something cool, like I'm walking around, and yep, there it is. Now we can save our script, we can get back here in Unity, and we will need to implement an instance of this class in a script that inherits from monobehavior, because we need to be able to test these methods. And in order to test these methods of the person's class, we need these start and update functions, because they are called automatically by Unity. So let's open this main concept script. And yep, I will not mind about these variables and methods that I already implemented in here, and I'll just start coding. Okay, so the first thing I will do is that I will create a variable. It can be public. The type of this variable, we treated the type float, we treated type string, but now we will use a different type. The type is person, the type that we created earlier. Okay, so the name of this variable can be person, and we need to create an instance of this class, otherwise we will not be able to use it. So to create an instance of a class, we type person, the variable, equals to a new instance of the class person. Okay, so we need to enter and finish this parenthesis in order to introduce the parameters to the constructor of this class. We will treat constructors later on this tutorial, but now I will keep it simple. And now if we type person and then a dot, we can have access to these public things that this class has, like ID, name, and the walk method. Now I can assign a value to the name of this person. The name can be like Paul. I can assign a value. Remember that we have to keep the type of these variables well defined. For instance, this name variable is of type string, so we need to type the value to it within quotation marks. And we can also define the value for a person's ID, and this value might be 1, 2, 3, 4, 5, 6, 7, 8, 9. And that's it. Now I can just put a print person dot name plus has ID plus person dot ID. So here I'm printing a variable followed by a static text and followed by another variable. Let's test this. Let's get back to Unity and let's try this project. Just remember to attach the script to an object. We do not have to type values to these variables right here. I will start my project, and then I have my print Paul has ID and then the ID of Paul, because we define these values right here. We typed that the name of this person will be Paul, and we typed that the ID of this person will be this value right here. So our print is correct. What about if we call this walk method of the person's class? We can type simply person.walk. To turn this into an interesting stuff, we can bring our script person. Let's modify it. We can put the name of this person before this this text, we can type, for instance, name plus, or maybe name is walking around. This will make more sense. Okay, so here we will be printing the name of this person followed by this text. Okay, so let's try this out. Here I'm invoking this walk method of the person's class. Remember to define a name to this person, otherwise you will not get the person's name in this print because it will be an empty string. And let's try. And there it is. Paul is walking around because Paul is the name of this person. What if we turn this walk method into a private stuff? Let's try this access level to private, and then if we try to access this walk method by typing person.walk, we do not have access anymore because it is a private method. A private variable or method can only be accessed within this class, within the class that define this method or variable. That's why our main concepts script cannot access this method. And if we force it, like person.walk, we will get an error. Basically, person.walk cannot be accessed because it is a private method. A private method we can use for initialization stuff, for internal stuff, from something that is internal in this class. Like this walk method can be public, and then inside this method we can invoke a private method. For instance, we can do this private void get tired. And here we can have a simple print. Print name is tired. And we will not be able to access this method here in this instance of the class person, like doing person.get tired, but we will be able to access this method in the walk method. So we can do get tired. Okay? This will bring us to prints. Oh, I forgot that I cannot have print in here. I need to have debug.log. Let's save this up. Let's try this. Now we got Paul is walking around and Paul is tired. We can have something even more cool. We can define a private bool which can be called tired, and it will firstly receive the value false. Okay? And then we type here if tired is equals to false, then we can print that Paul is walking. Otherwise, we will print something else. We will print name plus is tired and cannot walk anymore. And here in this get tired method, we will also set this tired value, this tired variable, to true, because we invoke this method get tired and the tired variable becomes true. And now when we invoke this walk method again, it will check this condition, it will fail, and then it will come to this else statement and print this value right here. So we can bring another function which is automatically called by Unity, which is void on disable. This is invoked when our script is finished. So basically, when we press the stop button, when we press this start button while in game, it will stop our game, and this method will get called. So we can invoke again person.walk. Okay, so let's try this. Entered in game mode. Paul is walking around, and then Paul is tired. And if I stop this project, Paul is tired and cannot walk anymore. That happens because when we first called this method, it will check if Paul is not tired. If he's not tired, it will print this, and then it will invoke this method, getTired. This method has this print and also has this command, which is setting the tired variable's value to true. And then when we come again to this walk method, which happens right here, it will see that tired now is true, and it will skip this first if. It will end up in this else and print this line right here. Okay? So this tired variable can only be modified inside this class because it is a private field. And if we try to force it to be like false by doing person.tired equal to false, we cannot do this because it is a private field, and we will get the same error that we had before right here. Okay, that is pretty cool. We got our class defined right here. We got our methods, we got our private stuff, but let's look at something. Here we have these two variable definitions, the variable name and the variable ID. We have to define them before initiating a new instance of the class person. But I told you about a constructor. When we open and end this parenthesis of a new instance class, we can put the values to the variables, and the constructor will do the assignments of the parameters to the variables that we want to assign values to. So let's define this constructor. A constructor will start its definition by the access level, which is public. Then the name of the class, which is person, and then we do not have a name for the constructor. That is the difference. We just begin our parentheses to enter the parameters that we need to receive. And the parameter that I want to receive is a string, which is the name, person's name, and an integer, which is the person's ID. These variables will be assigned to those variables right here. Okay, so what I can do is my string name, which is the public string of this class, will receive the parameter that is being passed through this constructor, which is person's name. So I will assign person's name to the name. And with the ID, I do the same thing. ID receives person's ID. The variable ID receives the parameter of the same type, int, string, string. So here we can do our assignments, or the things that are useful to us. In this case, it is useful to build a constructor which will assign the parameters to the variables of this class. So I will save this, and here in my main concepts script I can do the following. I'll not need to do this anymore because it will be implicit in the constructor. So I do the following: new person, and it is not updated yet, but this should take 2 arguments, those we defined here. I'll just save this and try again. I'll try it again. Person receives a new person. I don't know what's happening, but it is not recognizing that my person constructor takes these two arguments. So firstly, I will pass a string, which is the person's name. I can pass in like Guto, which is my nickname, and then I can pass my ID, which can be anything I want. Okay, so doing this is the same that doing person.name equals to Guto and then person.id equals to this thing that I typed here. But this is more simple and it is more compact, so we do not need to access the variables and set values to it because this will be implicit in the constructor, okay? So here in this person's class, the person's name becomes Guto and the person's ID becomes this value here. So the name receives Guto and the ID receives this parameter, which is that crazy number, and we will assign this crazy number to the ID in this constructor. So we will not need these value definitions anymore because this is implicit in the constructor. We can save this. I just can't try to access the entire variable of this person's class. And right here I get the same output except by the name, which is different. Here I get Guto is walking around and then Guto is tired. If I close this, I get Guto is tired and cannot walk anymore. So it is the same thing except by this useful thing called the constructor. So you get the idea. It's basically variable definition inside of the instantiation of a new class. Yep, and this covers our main idea for this video. So if you like, I hope you hit the like button, which is located above this video. I don't know, but you're probably seeing this button, so click it because it will help me a lot in the advertisement stuff of the channel and this video. Subscribe to my channel to receive this new videos announcements in your YouTube inbox. So yep, that's it. I hope to see you in the next video. Bye bye.